So, improving browsers in new ways. Today, I'm pretty excited to tell you about some of the things that we're doing with Gears, some of the ways the project is evolving. And I think it's going to be a pretty exciting glimpse into what's happening around the Gears project. So with that, I think we'll go ahead and get started. So to begin with, let's quickly recap what Gears is about. And it really boils down to three main things. So first of all, Gears is about extending browsers. At its core, Gears is a set of JavaScript APIs that we add into browsers that you can call from your web applications. Nothing more than that. One of the other key things about Gears is that it's open source. So we don't want to carve out a new ecosystem that's totally isolated from the rest of the web app space. We want to provide a set of features that anybody can contribute to and that anybody can feel free to pick up and use in their applications. We don't want this to be just a Google thing. We really want it to be something that the community benefits from. And then third, it really has to be ubiquitous. So that means that we don't want these APIs to exist only on a certain set of browsers or only on a certain set of platforms. In order for these APIs to be useful to you, the web development community, they have to exist everywhere. They have to work across Mac and Linux and Windows. They have to work on Firefox and Safari and Internet Explorer. And you also want them to work across mobile browsers and desktop browsers as well. So those are the key points behind what Gears is about. Now, we launched Gears about 1 year ago today at the last Google Developer Day. And so this is kind of our birthday. And as with any birthday, there's some exciting news, or like any good birthday. And they relate back to these 3 points. So on the ubiquity front, we're doing work now to support Firefox 3 as well as Safari. And also, Opera is bringing Gears to Opera 9.5. That's going to be available not only on Opera Desktop, but also on Opera Mobile, which is popular on quite a few phones. On the open source front, we're announcing today that we're going to debrand the Google part of Gears. We've always seen this as a project that really is aimed at the entire web development community, not something that's Google-specific. And just to make that clear, we want to change the name to update that fact. So in the rest of this talk and going forward, we're just going to call it Gears. And then finally, and I think this is the most interesting area, I'm going to talk today about how we're extending the web browser in new and different ways. New APIs we're looking at adding and things that we can do to make web apps even more powerful than they are today. So I think this is probably the number one misconception about Gears, and that's the feeling that it's just about offline. And if it were just about offline, I think most of us on the project would be kind of bored at this point. But really, we see Gears as about quite a bit more. So it is true that the first round of Gears modules were focused on offline. And those 3 modules were the database, the local server, and the worker pool. And the reason we chose those modules initially was because that was a big pain point for web applications. Not being able to use your application offline was something that really hindered them in terms of how useful they were compared to desktop apps. But kind of all along, our goals were a little bit bigger. And I think the best way to describe it is with this quote. You can think of this as the Gears vision. We want to make it so that web applications can be just as powerful as desktop applications. And we want to do that by unlocking the capabilities of the local machine. So think about it. I've got this laptop in front of me, or even if I've got a powerful smartphone, and I've got a CPU with gigahertz of CPU power. I've got gigs of RAM. I've got hundreds of gigs of hard drive space. Most web pages and web apps that you see aren't taking any advantage of that power. Sometimes you get a blink tag. That's not really using my 2 gigahertz CPU. So another way to think about this is, if you are using a desktop application today, what's missing? Why can't it be a web application? And I think when you think about that, you can figure out that, there are sets of APIs that if they existed in the browser, you could make web apps that are just as powerful as desktop apps. That's the kind of thing that long-term we're hoping that Gears will help enable. So as I said, the answer here is really to expose new modules through Gears, provide new features, new APIs that you can use to do more powerful things. And we don't want to just provide a grand framework of a grab bag of modules. What we want to do is fix real-world pain points, things that today are causing problems for web apps, things that are real issues if you're trying to deploy something. And at the same time, we don't want to solve the problems in a very narrow way. We want to provide general-purpose building blocks. We think that things like XML HTTP requests are a great example of the community taking a feature and using it for something that's much more powerful than maybe it was initially intended for. And finally, we want to make sure that we expose these features safely. What I mean by that is web apps have a huge advantage today over desktop apps, that there's almost no barrier to entry. And the reason is that I can send you a link, and you can click on it, and you don't have any fear that the application is going to take over your machine. And there's also no cost for installing the application. You just click on it, and you start trying it. If you don't like it, you navigate away, or you close the browser. There's no problem around security there. Everything in the browser is inherently safe. And we want to make sure that as we expose new APIs, we keep this advantage of web apps. It's one of the key things we think that differentiates web apps from desktop apps, and one of the reasons we're excited to make more and more applications move toward being web apps. So a couple things that I want to mention before we get into some of the details. And the first is that, as I said, Gears is an open source project, so all this stuff is happening in the open. All the topics that I'm going to discuss today have been mentioned on our mailing list. The source code is all available in our SVN repository. So I think that's important to keep in mind. The second caveat, though, to that is that these things are all exploratory. So today we're not announcing new APIs. We're not promising that these features are going to be in a particular version of Gears. It's kind of just a glimpse into what we think is possible, a set of prototypes that we've created that we think are very powerful and very enticing. And we're happy to share them with you today and kind of start getting feedback from the larger community. So with that, let's start diving into some of these pain points and some of the possible solutions. And I think the first one that's really interesting is desktop shortcuts. This is something that it seems like a small thing, but not being able to get into your application quickly and easily is a very subtle and important pain point and a disadvantage that web apps have relative to desktop applications. So I'd like to give a demo of what I'm talking about. I've got a set of demonstrations today and prototypes that I want to show off. And each time I want to load my demo page, I've got to type a bunch of text. Even with the help of tab completion, I've got to type a bunch of characters to get to the page. And every time I want to load the demos, I've got to do that same thing. It's kind of silly if you think about it compared to how things work on the desktop apps. And sure, there are a couple things you can try to do to make it a little bit easier to access. You can drag a fave icon onto your desktop. But this has problems. First of all, look how low-res this icon is. It's not really what I'd want to be the forward-facing version of my application. And even worse than that, the title here is not even controlled by me. So this is just whatever the title of the page happened to be. Realistically, I don't want this to say main index. I just want this to say Google I/O demos. And that's even assuming that you can get out your users to drag this onto their desktop. I think a lot of us are familiar with the gold bar issue, where in order to tell people how to get around the gold bar, we have pages that say, hey, please click up here, and arrows pointing into the Chrome of the browser. It's kind of annoying, honestly. So how should this work? Well, the application itself should be able to say, hey, user, would you like to create a shortcut? And so that's what we've done here. I say, yeah, I'd love to. I'd like to create a shortcut on my desktop. And now it's done. You can see the icon here is a lot higher resolution. And also I had full control over the text that got displayed as the title of my icon. And if I ever want to get back to that demo page, I just double-click it, and there I am. So I think we'll go ahead and kill this icon and just use this one for the rest of the talk. So a couple notes about that API and what's happening under the covers. First is that when I click that link, it's actually launching whatever browser I used to create the shortcut in the first place. So if I'm using different browsers for different applications based on what I prefer, the desktop shortcuts will actually launch whatever browser I want to launch. The second thing is, I'll show the API details in a second, but we've chosen a specific set of 4 icon sizes. And we picked those so that these shortcuts would look great across all the platforms that you as a developer would care about. So as long as you provide those 4 shortcut sizes, you don't have to worry about what platform a user might be running on. We automatically pick the right one and make it look good. And the other interesting thing to note is that because of limitations of desktops themselves, you can only have one shortcut for any given name. So you can't have 2 things that are both mapped to mail. Just something to keep in mind as you use this API. So let's look at some of the details of this API. What we've tried to do with all these things is to make them very simple to use. And we want to make sure that the powerful things are possible, but the simple case should be very easy. So in the case of the shortcut API, it's a method that hangs off the desktop module. And it just takes 4 parameters. It takes a name that we'd want to appear on the desktop and a URL to launch. It also takes that set of 4 icons I talked about, and an optional description if you want to provide more information about what the user is doing. So I think it's enlightening to go through a short snippet of code just to see how easy these APIs are to use in practice. So I'm going to do that for each of the APIs I talk about today. And if you've done any programming with Gears, this first line will look very familiar to you, the factory.create call. Every Gears API starts with this entry point. And so in this case, we say we want to create a desktop module. And then from there, all we do is call create shortcut. We pass it a title of our shortcut, an URL, set of icon URLs, and then a description. And that's it. That's all there is to it. Very simple, very easy to use. Now, the second area that I want to describe today is desktop notifications. And if you think about it, web apps have this problem where they can't really tell the user about important things that may be happening on their system. There's just no good way to notify users when something important is happening. So let me give an example of this. Here's what happens today if we're using a typical web app. So some applications will try to use an alert box. And so we'll be happily using our application, and then all of a sudden this will pop up in the middle of our screen. And it has a few problems. First of all, you'll notice that the title here isn't controlled by the app at all. So it says the page at http://localhost says. It's probably not that useful to the user. And then there's no formatting at all inside this box. So it says here, please notice this important message. This is probably not the kind of UI that I want to present to a user if I really want to get their attention. There's other problems with it as well. So if I happen to be browsing on a different page and one of these alerts comes in, I'm happily typing away, and then I get jarringly taken back to this page that set off the notification. So again, just a terrible user experience. Now, there's other hacks that people sometimes use. One of them is to scroll the title of the window. But this isn't all that great either. It has the same problems in terms of formatting, where I don't have any control over what it looks like. And it's actually pretty easy to miss, especially if I happen to have this browser minimized. I don't know that this title was changing. And now I look back here. There was something about fired. I don't know what that was. Probably wasn't important. So what should this work like? Well, ideally, I'd be able to say, hey, I'd like to tell the user something important, and a notification would pop up as a toast outside the frame of the browser. And in this case, I see I have an important meeting that came in my mail. It's 6 p.m. in John's office, and he's giving away free money, so I'm probably going to go show up to this meeting. Now, there's some other cool things that we can do when we have toast that appears outside the browser. If we have multiple notifications come in, we can make sure that they stack correctly. So instead of them fighting for screen space and overlaying on top of each other, they stack one on top of another, so I make sure that I don't miss anything. And then finally, let's say that I happen to close my browser because I want to do something else. Well, you'll notice here that even though Firefox is closed, this notification still comes up. And the reason is that we've got a small component running outside the context of the browser that these notifications can still be displayed from. So all in all, I think a much better experience than trying to show an alert box or trying to play games with the title of the window. So as I mentioned, there's a small out-of-browser component that's running. It's very tiny, about 50 kilobytes, and that's what's actually doing the display of the notifications. What we would like to do is also support existing notifiers. So if you're used to using something like Growl or another notification system, you don't want these notifications to fight with each other. You want them to coexist nicely. And so as much as possible, we want the Gears notification module to be able to talk nicely with these existing notifiers. We'll take a quick look at the API here. So in this case, the prototype, again, hangs off the desktop interface, or desktop module, rather. And it's just 3 simple methods for showing notifications. There's a way to get a notification object. There's a way to, once you've modified the fields of that object, to add it to the notification system. And then if you wanted to remove it later because, say, a meeting is no longer valid, for example, you can remove a notification. And then the notification object itself is also quite simple. There's a few fields here, very natural. There's an icon and a title, and there's a subtitle and a description. And in addition, if you'd like to show a link that will launch a certain URL, you can add that as an action. There's also a way to display a notification at a particular time. So this is useful, as I mentioned, if you close the browser, but you still want a meeting notification to show up at the right time. So this is a real-world code example. You can see that it looks very similar to other Gears modules, of course. It starts with a factory.create call. And then once I've created my notification object, I just set the 4 properties that I care about, and I call add notification. I'm done. That's all there is to it, to show a notification with this API prototype. All right, so let's switch a little bit and move on to a different area that I think is interesting. So the file system. I think that it's not immediately obvious what's wrong with file system access today, but I'd claim that there's actually a pain point that a lot of us have encountered pretty frequently, and that's if we need to upload multiple files to somewhere, selecting each of those files individually is incredibly tedious. And a good example is if you're just doing attachments to your mail program, or if you're uploading files to a file sharing site, or a photo sharing site, rather. So let me show what I'm talking about here. So today, let's say I want to select a bunch of files to be uploaded to my favorite photo uploader. I have to individually browse to my directory that I care about. I select a file. I'd like to select all the files in this folder, but if I try to, it doesn't work, right? Because there's a limitation of the file input element. You can only select a single file. So the hack that most browsers end up doing is to provide a link to select more files. And individually, I need to select each one of these that I care about. And you can see that even with a small number of files to upload, it's quite tedious. With a large number of files, it would be maddening. But there's really no reason it has to work that way. What I'd like to do is just say, hey, I'd like to be able to select all the files in this folder, open them, and now I'm done. And I don't have to deal with all these tricks around selecting files individually, grouping them all together, and then sending them off. Much more natural. Seems like this is really the way things should be. So a couple things to note about that API prototype. First of all was that it had the native OS look and feel. We weren't providing a custom Gears-specific dialog. We want this to feel very natural and work just like you'd expect file selection to work. The other interesting thing is, remember I talked about security and making sure web apps are not doing anything beyond your control. So it's important to note that that access didn't persist. Once I said I'd like to give access to these files, that's a one-time operation. The web app doesn't have permanent access to those files. And I'll explain the details of how that works in just a second. And finally, notice that the user had full control in that case. The application was able to say, I'd like to ask the user what files to load. But beyond that, the web app couldn't say, start in a particular directory or choose a particular file. The web app could simply say, I'd like to ask the user for a set of files. So much like the file input element today. The API, again, is very simple. So there's a file system module in this prototype, and it has a load files method. And I can optionally pass a set of options to that method, and those are listed here. For example, I can say I'd like to only accept certain MIME types. So if I want to just say images, I can pass that in. And I can also say whether I want it to be a single file or multi-file selection. One thing that we've tried to do here is we've tried to map this pretty closely to the HTML5 file input element. So as much as possible, we want these things to be pretty familiar to people rather than trying to train web developers to understand a whole new set of APIs. Now, you notice that the load files method returns a file object. And the file object itself just has 2 properties. One is the name of the file, and this is with any path stripped off for privacy reasons. And the other thing is something called the blob of content, which I'll get to in just a second. You can imagine other interesting things hanging off this file system module, like a way to save a file out to the system if you have a blob that you want to save out. So I mentioned this thing called a blob, and you're probably scratching your heads thinking, what is he talking about? That makes no sense. But I think the blob is actually one of the most interesting things that we've prototyped in the new set of Gears APIs. And here's what it is. It's pretty simple, but it's basically a completely generic interchange format for doing interesting things with binary data in JavaScript. So today, you know that there's no byte data type in JavaScript. There's no way to manipulate binary data. And it's actually not quite as much of a problem as it might seem, because in most cases, you don't actually want to change the bytes themselves. You just want to be able to do interesting things with a chunk of bytes. One way to think about this is it's similar to a file handle, in that you just have a reference to a chunk of data, but you don't actually necessarily manipulate it. Well, in the case of a file handle, you do, but not in the case of the blob API. One of the great things about this is that the blob fits in very naturally with almost every existing API that we have. So in the case of a database, you can imagine saving a blob's contents out to disk and persisting it for later. You can imagine HTTP request send taking a blob as input and being able to send it up to a server that way. You can imagine being able to take a blob and send it over to a worker so that it can be operated on in the background. One way to think about this is that any method that takes a string today could be extended to take a blob, and it's actually not that much different in terms of how you would use these APIs. So again, this is completely generic and something that we think will be a very powerful thing for web apps to have access to. So looking at the blob interface itself, it's very simple, and this is by design. We only expose two properties on blobs, and one is the length, and the other one is a way to take a blob and get just a subset of it using a slice method. Now, a couple things to note here. First is that blobs are immutable. They're read-only. So that means that if I get a handle to a blob, I'm not going to directly modify the bytes. And the reason for that is it gets very tricky if you try to modify the bytes directly. So let's imagine that you're using XML HTTP request send and doing it asynchronously. If you pass a blob to send and then you try to modify it, what gets sent? The version that you originally passed in? The version that you've changed since then? So it gets very hazy. And there's also performance reasons that blobs are immutable, that you can't change the bytes directly. Now, what you can do is you can pass a blob to a method, and it can return back a new blob that has any modified contents that you care about. So it's actually not a limitation in practice. Now, I said that one of the cool things about blobs is that it has a lot of uses. And so I want to give an example of just one of those uses. And I'll do that by describing another pain point. There's a problem today if I want to upload a very large file that if anything happens in the middle of that upload, any network hiccup, just the smallest thing, that post is going to fail and I have to start over. It's especially maddening if I'm trying to upload large video files or any large content at all. So let's take a look at what happens today. Let's see, I'm trying to upload a video to my favorite video sharing site. Let's find a good video to show. Oh, probably, let's not show this one. I think there's enough of those on YouTube already. Instead, let's upload the second video. And here's the experience today. I start the upload, and there's no progress at all. I just see that something's happening. I hope that something's happening. And if ever there's a disconnect, I'm out of luck. If there's an error, if I walk away from my machine, I happen to come back, this is not the message that I want to see, that there was just an error sometime during the process. So it's a pretty bad experience. Well, what should it be instead? Well, I should be able to say, hey, I'd like to add a video to this list. And I click upload. And there's a couple cool things here. Remember that last time I did the upload, there was no progress happening. So there's no progress happening right now. Aha, smart audience. I planned that, yeah. So the cool thing is now that I have a connection, it automatically resumes. I didn't have to do anything special there. And the other great thing is that I actually get progress now. So unlike normal upload, where I wouldn't know how far I am, this I actually get progress to know how far I am through the upload. So I think it's interesting to look at what's happening there. We didn't have to expose a new API at all to make this possible. All we did was take the existing blob API and the fact that you can send blobs with HTTP request. And so here's the pseudocode for what resumable upload looks like in terms of an API, quote unquote. Basically, you just take the entire blob, break it up into chunks of some size. I've chosen 1 megabyte in this example. And for each of those blobs, send them up to the server. If any of one of those fails, then try again. If not, continue at the next point in the sequence. So I think this is important to note how composable these features are. Like the fact that we can do something as interesting and powerful as resumable upload, but without adding a new special purpose API. We've done it by having more general purpose building blocks that we've put together. And finally, the last thing that I'd like to talk about is geolocation. So it's not only the raw CPU and CPU power and disk space and RAM that we have available. There's oftentimes interesting peripherals that the machine has and interesting things you can do with those peripherals. So think about if you ever try to enter your location in a location-based search. It's a pretty unsatisfying experience. So let me give an example here. let's say that I'd like to find a place to get a beer after this conference. And you think I'm joking, but I really do want to get a beer after this talk. So today, here's what it looks like. I say search for beer in San Francisco. And I found 10 results, and they actually are pretty high-quality results. But the problem is that they're spread across the city. They're 5 miles apart. And we happen to be around here on the map, but I probably don't want to walk 3 miles to go get a drink. Instead, what I'd like to do is say, hey, use whatever information you have available to figure out my location at a much finer granularity, and then send that up to the server. And so if we do that instead, oh, and by the way, for the purposes of this demo, my laptop obviously doesn't have a GPS device, so I've mocked it up to return the data that a GPS device would return. So now I say search for beer, and we see that, here we are at Moscone Center, and we've got 10 places that are all within 2 or 3 blocks. Sounds like a much more satisfying beer drinking experience. So what's happening here? How does this work? Well, I mentioned that we could use GPS to figure out the location. There's also other interesting things that you can do. So the fact that every Wi-Fi access point and every cell ID tower has an ID means that using the position of those access points and cell towers, we can figure out locations based on those signals. And then the IP address is also a very, very low resolution signal. But by combining all these, whatever information is available on the local machine and sending it up to a location server, we can actually get back pretty high quality results. If you've ever used the iPhone's map feature, you've probably seen this in action, where it also uses Wi-Fi access points and cell ID towers. Now, the service provider that we send these signals up to is completely customizable by the web application. So we don't want to lock anybody into using Google or any particular service. There will be a free Google service that applications can use, but if somebody wants to use a completely different service provider, it's totally up to you, totally customizable. So again, a quick look at the API here. There's a way to get the last position, and this is a way to get data immediately back. So there's no delay waiting for this to come back. There's also a way to say, hey, I'd like you to use all these signals, send them off to a server, and then let me know when you get the data back to figure out my best position as of right now. And that's the get current position call. The options that I mentioned earlier, things like location provider, that would be provided here through the position options. And then finally, there's a way to say, I'd like to watch the position as it changes over time. So if I want to do something like a mapping application where, as I'm walking around, it updates my position, I could use the watch position API to do that. In terms of what data you get back in the position object, it's pretty natural. It's what you'd expect. You can get a latitude and longitude. You can also get an altitude. And then you can get accuracy fields for both of those. You can figure out horizontal and vertical accuracy. And then finally, there's a timestamp to know when this position was last fetched. In terms of usage, this should all look very familiar by now. But again, factory create to get a geolocation object. And then from there, we just call get current position with a function. In this case, the function calls update map when it gets back that position object. Same thing would work if you wanted to watch the position over time. It looks exactly the same, as you can see. So very easy to use, and something we think will enable quite a few interesting applications that can take advantage of geolocation information. So finally, what's next? I've talked about a set of APIs here and things that we've started investigating to improve the capabilities of web apps. Where do we go next? And it really comes down to remembering that vision that I mentioned at the start of the talk, that we want to continue unlocking these inherent capabilities of the local machine, the CPU power, the disk capacity, the fact that there's interesting peripherals attached. Those things should all be available to web applications. Web apps shouldn't be hindered just because they aren't desktop apps. And we think that we can expose these features in a safe way that doesn't violate this inherent advantage that web apps have, the advantage that there's no penalty for trying out a web app, there's no install cost. It's basically, I get a link, I can click on it, and if I don't like it, I navigate away. And I'm not worried about what might happen to my machine. And finally, open source and open standards are something we believe very strongly in. We're working hand in hand with the W3C and the WhatWG committees. We want HTML5 to evolve to include as much power as possible. And whether it's Gears versions or other versions, we're not trying to carve off our own space. We really want browsers to be more powerful as a whole. We think that the community everywhere benefits, not just Google. Aaron Boudman is giving a talk tomorrow morning, and he's going into a lot more detail about how Gears is working with these committees and what we're doing to try to do the right thing. I highly recommend the talk. And finally, I'd like to say we encourage everyone to get involved. We really do want people to contribute from the community. And there's two obvious ways. One is that if you're writing a web application, you can use the Gears APIs. And we've got an APIs page on code.google.com that goes into all the details of what we provide and how to use the APIs. And then if you'd like to contribute to Gears, we highly encourage that too. So we've got an open project on code.google.com. Again, as I said, all the source code is up there. We've also got links at this URL for the mailing lists that we use. And our discussions are all happening in the public. It's not a secret. The stuff that I described today is all happening there. So we really do want to encourage the community to get involved. We see this as something much more than just a Google initiative. This is something that really is about improving browsers so that all of us can do more interesting things with web applications than we can do today. And so with that, I want to open it up and take questions that you have. But thank you for your time today, and we hope you'll try out Gears. And we have 2 microphones here, so if you could, please use the mic when you ask questions.
You mentioned integration with Safari, so are you looking to tie into the HTML5 support that's in WebKit right now for in-browser database, stuff that points to the data URLs accessing file systems? Is that the...
Yes, the question was, how is Safari support going to work given that HTML5 database is in Safari? So it gets a bit tricky to provide that ubiquitous aspect, the fact that the API should work the same everywhere if we just tied into the HTML5 version, because there are slight differences. So what we'd like to do is we'll provide versions that are compatible across all browsers. And it's actually not such a bad thing if there are multiple implementations. In fact, if anything, it makes it simpler for web developers because they don't have to write their code separately each time.
Yeah, because you could actually point on Mac OS, you can point to SQLite, it's there. And that's kind of an implementation across because, Debian's got SQLite, Gears, and Air apps have those. So that's kind of a standard de facto coming up. Either do it in the browser cache, use that as like a big mem cache, speaking to a local database, and you basically have a full-on direct-to-web app there.
Yeah. So the point was that with SQLite, you can actually reuse some of that stuff. I mean, as much as possible, we want to make it so that if there are any differences that are forced because of just the programming aspects of how Gears works, Gears provides new JavaScript APIs. There's certain things that are tag-based in the HTML5 spec, and there's just no good way for a browser extension to provide new tags. It affects layout and rendering and all that kind of stuff. So what we want to do is if there ever are differences that are forced because of technological limitations, we want to make sure that the differences are as small as possible. So ideally, there would just be one switch point at the top that you point at a different object to create it, and everything else is exactly the same.
How do you convince your users to install Gears?
The question was, how do you convince your users to install Gears? So what we've seen is that Gears installations have really been driven by application features. When Google Docs launched with offline access, there was a huge number of users that were willing and didn't mind at all to install Gears because it gave them something they could never do before. I think over the short term, that's going to continue to be the case, that applications that are cool are going to drive Gears, and that the features are going to be compelling enough that there isn't a big barrier to entry. I mean, the Gears install itself is very small. And so I think I would say, you'd be surprised at how many users will install Gears if you use it.
The reason I ask is because, I use other Google apps, but I still haven't installed Gears just because, I don't know, I'm lazy. But in the keynote, or in other instances, people have said, in certain applications or in certain environments, it's locked down, users can't install third-party applications. Is the hope that it's going to meld so much with HTML5 that Gears almost won't be needed because it'll be a standard, or is it more that it'll be like Flash and IT admins will be forced to put it on all machines?
I think both of those are happy outcomes for us. I mean, both of those get to the end goal of making the browser more powerful, giving it more capabilities. So whether it happens through widespread adoption like Flash, or whether it happens through getting features into the browser through HTML5, we're happy with both those outcomes. I think realistically, something like the widespread adoption is probably more likely. Question over here?
So you talked about all of these APIs, one of the goals being to extend the browser safely, extend the platform safely. The one concern I had is around the geolocation API. It seems like there's a privacy concern there. Like any website that I go past that has JavaScript enabled, if the user has gears on their machine, you know where I am.
Yeah, so it was a good question. The point was certain APIs like geolocation, you want to make sure that the user knows whether they're giving up their location information to the web app. So in this prototype, we didn't show it, but we are looking at different ways. I mean, there will have to be some way that the user gives permission to the application to use location information. We haven't figured out what the right model is yet. As much as possible, we'd like for any permission that the user gives to be based on their actions, so that there's not a big dialogue that comes up that asks, your mom or your other, less savvy users, hey, do you want to enable SQLite access? It'd be kind of silly. So there has to be permission for using the location data, and we just haven't figured out the best model yet, and we're looking at different things.
Cool, thanks.
I'm curious to know about the dependencies for Gears. Does it run on a Java machine, virtual machine?
Does it run on a Java? So the question was the dependencies in Gears. There are no dependencies in that it's self-contained. You install Gears on a machine, and from there it supports itself. So as long as you are running on a machine that Gears supports.
So it's not platform independent then?
That's correct. It's not platform independent. Okay. We have versions that run on each platform and are suited just to that platform.
Okay. I think I saw just a title for one of the Charles about Gears for Windows Mobile, I think. Is that the only mobile platform you're currently supporting?
That is currently the only mobile platform that's supported, but we're looking at more as well.
Okay, interesting. Thank you.
Yeah.
Just back to the earlier question about the geolocation and security. Are there any other areas in which you're drawing the line as far as how open you make the browser sandbox?
Sorry, I didn't catch the last part of that.
Just are there any I know you said you're still looking at how to make the browser more open but still keep it secure. Are there any other areas where you've specifically drawn the line and said the sandbox idea is a good idea and we shouldn't go beyond this?
So I guess the question is, are there other places where we've said we think the feature is more compelling than the security aspect? Or where we've bent the security constraint?
Yeah, have you drawn any firm boundaries? The browser.
As far as guidelines around security and what should be exposed and what should not. As a general rule, what we've decided is that you can look at certain features and say that they're safe in themselves because they're kind of sandboxed. So things like the SQLite database, you can only write and read from a sandboxed area, and so there's no risk of your data getting out of that sandbox. In the same way, the worker pool is running in its own space, and these things can use resources, but kind of the stand we've taken is that as long as they don't use too many resources, that's all right. So we're users too. We want to make sure that these web apps that may be misbehaving aren't doing stuff that we wouldn't enjoy. But yeah, as a general rule, sandboxing is one good way to go. And in the case where it's anything involving the user's private data, it has to involve a prompt or some kind of action that the user explicitly takes, and they know that they're exposing that information to the web app. That's kind of our stance.
So I got a couple of questions for you. The first one, the HTML5 spec only has a database, right? Not the local server or the worker pool. Just wanted clarification. That is correct?
No, HTML5 does have a version of local server. I forget the exact name of it, but it works slightly differently in that all the URLs you can capture any URL, not just ones in your security origin, but they're scoped to your page. So only when you access those URLs from your page do they get served out. So that's how they solve the issue of making sure that you can't capture a bad version of somebody else's page.
Okay. The second question, you were talking about storing JavaScript objects as blobs, but any plans on supporting just JSON objects, JavaScript objects just directly maybe in the database and then being able to retrieve them? Because it can be, we have a great need to support JSON objects. We just use JSON so much, but we don't want to be, we want to use the offline capabilities of Gears, but we don't want to get into this blob business and then trying to do all the splits and all those kind of things. But
yeah, the question was, are there plans to support JSON across more of the APIs? And I think as of about a week ago, we added support for being able to pass any JSON object to a worker. So rather than having to bundle up the object yourself, you just pass something and it all gets sent across transparently. We haven't looked too much at the database side of things, but let us know on the mailing list exactly what you're thinking of, what you have in mind, because it may be a very natural fit. Thanks.
I was wondering, is there any plans to have gears implemented with Google Maps, say you're going on a route somewhere and you have no internet access, but you'd like to have the tiles preloaded in the schedule?
So the question was, are there any plans to integrate Google Maps with Gears? And the answer is that a lot of that stuff is honestly out of our control. I mean, we work on the piece that you see on the public forums, the stuff that gets you access to the capabilities of the machine. But there are completely separate teams that work on maps and work on docs. In fact, Steven Saviano gave a talk today about docs specifically. I mean, we would love for that kind of stuff to happen. We think that there's a lot of compelling cases where you could use Gears. But as far as concrete plans, I mean, it's kind of out of our control.
Does the blobs API reference files on disk? Like if a user selects a file, for instance, for uploading, does it reference that file directly, or do you have to load that into memory first?
The question was, what do we do in the case of blobs for accessing files which may be very large? Do we load them into memory, or do we just give a reference to it? It was one of the tricky things that we talked about a lot, and what we settled on, at least for now, was that it's a reference to the original file, but with the caveat that if the original file changes, we'll be watching for that, and the access to the blob may throw at some point. So, in other words, this is how we preserve the read-only and immutable aspect of blobs, but without forcing the entire file to be loaded into memory, which could be pretty bad on, especially devices with limited memory.
So if a modification happens, does Gears still have access to that file? Could it restart the read on that file? Is it a facility for watching a file for changes, for instance?
Yeah, essentially. I mean, the plan is to look at the modification time of the file when it was first blobified, and then every time there's a read done on that file to also check the modification time. If ever something has happened out from underneath you, the file is kind of invalid in the same way that on a desktop app, it'd be undefined what you should get at that point.
One last question. You mentioned that you were debranding Gears. Does that change the namespace too?
The namespace is the one area that we haven't figured out how to handle well. Because obviously, if we inserted an object called Gears into the browser namespace, that's much more likely to collide with existing variables. So it's currently Google mostly just because we can't think of a good way to not collide. And if there's suggestions, please feel free to post them on the forums. Thanks.
I have a couple of questions. So, are there any plans to extend the support to other operating systems, like Solaris?
To extend Gears to which?
To other operating systems.
Oh, so the question is, are there any plans to put Gears on additional operating systems? Mostly just on the mobile space. I mean, on the desktop space, it's more a question of resources that, the people that happen to be working full-time on Gears right now, realistically don't have time to work on some of this. I mean, it's just a game of numbers. So, we look at how many users there are in different platforms, and we carve off the biggest ones first. That said, if there's somebody who's very motivated to get Gears working on Solaris or another platform, contributions are definitely welcome. We'd love to have support everywhere.
You also mentioned that you added support to pass JSON objects to workers. What about getting JSON objects back from workers after they are done?
So JSON and workers, it goes both ways. I mean, instead of so right now there's a message object that you receive in a worker. There's currently a .text field. There'll be a .body field, and the .body field will be an arbitrary object rather than just the text version of it.
Thank you.
Just one question. Say you're developing an email application and you want to bring that offline. You look at something like Outlook where people are going around 4 gigabyte profiles. How do you determine how much is too much in the way of resources that an application using Google Gears can use?
So the question was, I said earlier that we want to let the web application use a reasonable number of resources, and how do we determine what's reasonable? So one solution that we haven't implemented yet, but we think is pretty compelling, is you can imagine using the same notification interface that I showed earlier to let the user know that their web apps as a whole are using more than some amount of disk space, for example. And at that point, the user can choose to do something or not do something. For me personally, if I had applications that were not misbehaving, they just happen to use a lot of space, I wouldn't want them to not be able to use that space. Yet at the same time, if there is something that's doing it out of my control, I do want to know about it. So we think the notification system is a good compromise, a good way to let people know if something's happening, but not force them to take action. I think things like database quotas, where you have a hard limit and all of a sudden calls start failing, it puts a lot of burden on web developers, and it's not a great experience for users either. So that's kind of what we're leaning toward right now.
In the meantime, is there a limit right now?
In the meantime, is there what?
Is there a limit right now?
No, there's no limit on amount of space that a database can use.
Thanks.
I was wondering if you could let us know if you knew any areas in which Gears is planning on extending the browser in the future, like 3D graphics or anything else like that.
Are there any areas where Gears is planning on extending the browser in the future, like 3D graphics? No, I think it really depends on pain points. If there's a lot of need for 3D graphics in the browser, it's something that I think it makes natural sense to look at. But right now, we're not doing anything in the tree around 3D graphics.
Hi. Hot Pressman with Bubbles, site-specific browser. Wanted to check if your implementation of uploading files, do you re-implement the HTTP request object? Do you have your own implementation to bind it with the binary objects, or do you use the existing ones?
Yeah, the question was, how does HTTP request work? What's the best way to describe it? Do we provide our own implementation, or do we shim down to the underlying browser implementation? We shim down to the browser implementation, but at a very low level. And the reason is that the API exposed on different platforms varies in subtle ways. And so we want to make sure that the API is consistent across all browsers. And so that's why we do it at a lower level. But at a higher level, we provide a Gears HTTP request object. And that's also what lets us support things like passing blobs into the send method.
Is this to the extent that you implement by yourself the whole multi-part encoding and everything?
So the question was, do we implement our own multi-part encoding? There is no multi-part encoding in certain browsers, at least today, but we are looking at ways that we could support multi-part encoding. In fact, that's a recent topic of interest.
Okay, thanks.
Thanks.
I'm wondering if there's plans to have for Gears to support more like hardware peripherals, webcams, other things that can plug into, say, a USB port.
Yeah, the question was, are there plans to support more things like webcams and other peripherals? I think the cameras in particular have been one area that people are very excited about. And there's also been some work that's been done in the public tree around audio APIs. So, a way to record sound through the microphone and also play back through the speakers. So, yeah, I think camera and microphone and speakers are natural peripherals that would make sense to start exploring at some point. And some work has already started. All right, I think we're all set. So again, thank you all for coming, and enjoy the rest of the day.